class. I know we did some review on the review packet. Um, I don't know, but I think it's period 6, no, period 7 didn't do that one. Just let me go over for the exam. No, for the exam, it will be very helpful. So let's do number B, letter B. No, number 5, problem 5, number B, letter B on the review packet. Here they ask you to find the curvature K, and you have this one. But the vector function is expressed in terms of S, and S is the arc length. You always saw the vector function expressed in T at time, but here is expressed in arc length. The way you have to use that formula K is the arc length is you have a 3 different formula. The first one is K dt over ds, but I advise you to use that one, R S vector, and you take the derivative, cross product of the second derivative of the vector function expressed in arc length, and make sure here is length, because remember the curvature is a scalar, and you take the second derivative of the vector function cube. Okay, now take the derivative for this one. We have to do that one. B R prime is, here is just 1 is I, and the second one is 0. So here we will have 1 and 0, and 0 if you want, but just leave it like that, is fine. Okay. You can also, okay, just let me express like this, so you won't have no problem for taking the matrices. Because here K is 0, everybody know it. And here you have this, and you take the second derivative with respect of S. If you take the second derivative, everything will be 0. And now you take the cross product for this one. If you take the cross product, you will have I, J, and K. Now here you have 1, 0, 0, 0, 0, 0. So here you can tell everything is 0. So then the K, the curvature here is just 0. That's it. Okay. Do the same thing for 8. Same process. Okay. Okay. From here, they ask you also to find the curvature. Just use the same tactic, but you just have to replace T by 1. Let's do just 1. Let's do 8. So if you do 8 and find the curvature K, and you can use that formula if you want, it's up to you. You can use that formula. You can use T or R. Either way will work. Let's do that one. The same formula. Take the length of the cross product, and you have the second derivative. First derivative of R to the third. Use that formula. So if you take the first derivative for this one, for 8, you will have 1 is I, it's just 1, I, and the second one you have plus 2tj, yeah, and you end up having 1, 2t, and 0. If you take the second derivative, you have this one is 0, I plus 2j plus 0. So you will have 0, 2, and 0. So now you take the cross product of this one, the cross product of r prime t cross product of r second prime of t. So here you can just replace t by 1 because here is t equal to 1. So you will have r second prime of 1. Now first derivative at t equal to 1, you have 1, 2, 0. So here you have I, J, K. And here you have 1, 2, 0, and 0, 2, 0. Okay. Here you can tell you only have k vector, which is 2, and you have 2k vector. Okay. Without the link, you can just do this one. So with the link of this one, cross product, you will have 2. Okay. Now take the link for r prime. We know r prime is here. If you replace t by 1, you have this one. So the link is square root of 4 plus 1 is just square root of 5. So now take the curvature here, you take the formula, and you have 2 divided by square root of 5. That's it. Okay? That's the way to find the curvature. And here use also the same tactic here. Nothing changed, nothing. But here the only difference is t is not given. Here is the same thing. Okay? Let me advise you something that thanks you have to take look at it on the exam. Let me open a new page here. Take a look at it when they ask you if you have any given vector function, you know is st plus yt plus zt. Okay. You have I here, you have j, and you have k here, vector. Or you can just write down after xt, yt, and zt. Now, the vector function is given like this. I have one question, and the question I'm about to ask is, found the arc length. If they ask you to find the arc length, of rt, or of the curve, if they ask you to find the arc length of the curve from the vector function, so you will have, just use the formula, but you have to define first L. Let L be defined as the arc length, okay? And you write down the formula. The arc length is the integration of the square root of the derivative of x t with respect of t square plus the derivative of yt with respect of t square plus the derivative of zt with respect of t, everything square. And make sure you put the square root until here. Okay, and make sure you put the integration here. That's the way to find the arc length. Okay. Now you have to take a look at it also if you have any given vector function. If they give you a vector function, or they can give you a vector function and they ask you if the vector function is smooth or not, or they can give you a equation parametric and they ask you if the equation, no, if the curve is smooth or not. Now you have two things, so I want you to understand because I may change the question anytime. Let, just for example, okay, here just for example, let R be a vector function, okay? Let RT be a vector function. So you have xt, for example, yt. Let's call it ft. It doesn't matter. It's just same thing. Ft, and you have gt, and you have ht. Now, is rt is the vector function is smooth, whether the vector function is smooth or not. Okay, I want you to remember the definition of the smooth function. What's the smooth function? I did it in class. I want you to go over and look at your notes. Take notes and look at it. Or also you can open the books. You can open the textbook and check what's the smooth function. What's the definition of the smooth function? Okay? First of all, so you have to take the derivative. Take the derivative and check at point if each of the components are non-zero. Also, the function have to be continuous. Also, the first derivative of the function have to be continuous. Okay? If it's that case, then it's smooth function. Let me repeat. The first things you have to do, you have to take the derivative first, the derivative of the vector function. Take the derivative. So, and make sure to prove the function is continuous. The first derivative of the vector function is continuous at, let's see, at t equal to t naught, and make sure at t equal to t naught, r t naught prime of v is non-zero. Mean it cannot be zero at time t naught. That's the definition of the smooth function. Okay? Just go look at it, and I give you a lot of examples in class. Check your textbook and check the example I give you about the smooth function. Good luck.